This is the 2014 higher tier non-calculator paper, and this is a guide to how to get a grade C. Similar to some other videos I've done, this is mainly meant for my class this year. It's not the whole paper, it's just how we get up to grade C on it. I've just been through the paper and looking at our sort of top 40 and the stuff we covered this year. There are 28 marks, 28 marks to get a C, 47 marks to get a B. On this paper there are 37 marks that we can definitely do with the material that we've covered recently and this year, and there's another 14 marks that we could maybe get, and actually there's an awful lot of marks on top of that for things like standard form, which I know some people have done, but I'm only sticking to the marks which we've done in Lessons with Everybody. Now the first question here, we've got dotted lines around these because I think we could tackle them even though we've not strictly speaking done them in lessons recently. We just have to remember the rules for fractions. So times in fractions, times the tops and times the bottoms, so 1 times 2 on the top, 7 times 3 on the bottom, and 2 out of 21 for that one. The second one here, 3/5 take away 1/3. Well, we need to make sure that we have common denominators here, so 3 and 5 both fit into 15. 1/3 is the same as 5/15, and 3/5 is the same as 10/15. 10/15 take away 3/5 is not the same as 10/15, is it? 3/5. 5 times 3 to turn into 15. 3 times 3 is 9, so 9/15 take away 5/15 is 4/15. Question 2, much more standard question here. Stem and leaf diagrams. So, stem and leaf diagrams, we've done these loads of times. This is a nice stem and leaf diagram question because there's a nice big gap to remind us that the thing to do is to first of all draw out the table. And we always do this twice with stem and leaf diagrams. We always make sure by the time we finish, we'll have drawn the table out twice. So we'll look at the numbers. We've got 13, 21, 34. So the numbers start at, there's a 5 there. So they start with no tens. Then there's some numbers in the teens, some in the 20s, some in the 30s, and some in the 40s. So that's our stems sorted out. Now we're just going to have to sort out the leaves here. So 13, that would go in there, 21, 19, and as usual I'm first of all putting them in without caring about what order I put them in, and we'll use the second diagram to order them. My advice is don't try and do two things at once, just put them in the first diagram, use the table that they've provided you with on the paper to order them. We should have plenty of time on this exam, we shouldn't be pushed for time. So you'll have time to do that. If you want, come back to it later on when you've done all the other questions, if you think this is going to take you a while to do it. 40, 16. Now I'm trying to speak and do this at the same time, so it's possible I've made a mistake somewhere. Just check what I'm doing. Okay, so there we go. We've got that. That's 1 mark so far. Second mark we're about to get now by taking this and put them in order. So 5 and 9 are already in order. So 3, 9, 8, 5, 6, 9. So that's going to be 3, 5, 6, 8, 9, 9. 1, 7, 3, 9. Again, we'll put these in order. So 1, 2, 3, 3. So let's just cross out the ones we've done. 5, 7, 8, 9. 1, 2, 4. 0 in there, and then the key, so I'm going to pick 1, line 3, and remember it's much better to write means 13 than it is to put equals 13 there. But 3 marks, 1 for this stage, 1 for putting the leaves in order, and 1 for having the key. Now this is a question which I was quite pleased when we did this on Tuesday this week. A lot of people in class this year got it right, and all we've got to do is make sure we remember to draw a two-way table for this. So we've got swimming, squash, and the gym, and we've got male and female people. And then we've got the totals, of course. Total, right, okay, so 21 women, so that's 21 women in total. 6 of the 8 people who played squash were male, so that's 6 male squash players, and the total number of squash players is 8, so that goes in there. 18 of the people used the gym, and 9 males went swimming. So males that went swimming is 9. And work out the number of females who used the gym. So it's this space here that we're really looking to fill in. So let's just fill the table in. Same as usual, we're looking for the only blank in the row or in the column. So I'm going to start with this column here, 6. So that would be a 2 in there. If there's 8 people who play squash and 6 of them are male, 2 of them must be female. What else have we got? Now I'm just looking, and I've made a mistake here because I've got 2 blanks in this column, I've got 2 blanks over here in this row, and there's no row or column where I've got only 1 blank. And I've just go back to the question, I've missed out, there's 50 people altogether, so there's 50 here. So let's have a look, we could fill in perhaps this number here. There's 21 female gym users, so how many men are there? Well, it's 50, take away 21, so that's going to be 29, and that lets me fill in this gap here. 9 add 6 is 15, so that's going to be a 14 just there, and there we go. We can have we've now got up to our final answer, which is just a 4 in here. 14 add 4 gives us 18. Okay, so the key is draw the two-way table out, and then make sure you fill it in one box at once. Okay, now we've got to read this question very carefully. A lot of people got some marks here. If we look at the bottom, there's 4 marks worth, but we've got to be very careful not to miss anything. So there are 2 children and Mr. Brown going to London. An adult ticket costs £24, a child ticket costs £12, and the family rail card gives us a third off adult tickets and 60% off child tickets. So we need 1 adult ticket for £24, and we get a third off that adult ticket. Well, 1/3 of £24 is 8, and we get a third off, so the cost is going to be 24, take away 8, so that's £16 for the adult ticket. We've then got 2 child tickets, so that's a total of £24 there, and it's 60% off, so we need to find 60% of 24, or well, let's do it this way. There's several ways to do this, but again, most people in this class do it this way. So 10% of 24 is 2.4, so 10% of £24 is £2.40. So we now need to times that by 6 to make it up to 60%, and you might want to double it to get 20% and then times it by 3 or something like that. But £2.40 times by 60%, however you do that, we're going to get £14.40. So there might need to be some working out in here that you've done extra. Now, if you read it, it says 60% off, not 60%. We don't pay 60%, we get 60% off. So the cost of those 2 child tickets is £24, take away £14.40. And that's going to come out to £9.60 if we work that out. Again, whichever way you work it out is fine, but £9.60 is the answer that we're going to get. So we've got £9.60 for the child tickets, £16 for the adult ticket, so that is £25.60 in total, and we got that from 16 plus £9.60. Oops, £9.60. Again, apologies for the handwriting on this iPad, it's quite difficult. Rebecca wants to find out how many books people buy. She's going to use a questionnaire, describe a suitable questionnaire. Question. Okay, so again, a pretty standard question. We'd want to say something like, how many books do you buy in a week, or how many books do you buy in a month? Make sure you've got a time frame in the question, and then the easiest way not to make a mistake on this would be to have 3 boxes, and we'd say 4 to 6 books in the middle box, less than 4 books on the left-hand side box, and more than 6. Let's see if we've got time to squeeze one more in before my class arrive. Okay, so this one has got dotted lines because a bit of a tricky one. 2m times m is 2m squared. 2m times 3 is 2 times 3 is 6m. Okay, and don't forget that m on the end there. Part B, quite a tricky one. We're trying to make the brackets here, but there's a 3 and a 6, so I can take a 3 out the front. There's an x in both expressions, so I can take an x out the front, and there's a y in both expressions, so I can take a y out the front. 3xy, well, to turn into 3xy squared, we're going to have to times that by y, and times it by 2 to turn it into 6xy. Now this one here, I wouldn't expect many people to be able to do, but some people had a go at it, and 1 or 2 people even got it right, so there's a quick run through it there. As you just heard, the bell went about a minute ago, so I will carry this video on, carry this paper on rather, in another video. Okay, so this is the continued June 2014 non-calculator paper. I think I might have managed to make this all part of the same video, but it might be the second part of the video here, who knows. Right, okay. So, this diagram shows a plan of a small field, and we're going to keep pigs in the field, and each pig needs 36 square meters, so we need to know how many pigs we can keep in here. We should notice that this is a starred question, so we need to watch out for showing working out here. So, the first thing we'd need to do is find the area of the field. So this is shape A, this is shape B, and this distance here is 9 meters. So shape A, so area of shape A rather is 10 times 7, which is 70 meters squared, or square meters. Area of shape B is 9 times 6, which is 54 meters squared, so total area is 124 meters squared. Now each pig needs 36 meters squared, so the next thing we're really trying to do here is 124 divided by 36, but we don't need an exact answer, we just need to know how many 36s fit into 124. We don't need to know about the remainder or the decimal part of the answer. So if we just think about that, 36 times 2 is 72, 72 plus 36, so 36 times 2, so 36 times 3 is going to be 108, and 36 times 4 is going to be bigger than 124, so it's going to be 100 and, well, it's certainly more than 136, isn't it? 108 plus 36. So another way of thinking about that is that 108 plus 36, well, it's 136 plus 8 if you think about it that way, or we could just do it as a column addition like this. But either way, we're going to get 144, which is more than 124. So our final answer is 3 pigs. So the way that we're going to set that out is we'd maybe say 124 divided by 36 is 3 remainder. Oh, I've rubbed out the right working out now, but whatever the remainder was, 3 remainder something, so it's more than 3, less than 4. That's all the important information we need. But remember, it's a starred question, so make it clear what working out you've done. Now, question 8, this is a locine constructions question. Several people may be able to tackle this. I'm not going to cover it in this video, but you may be comfortable with it and get a few extra marks here. We haven't done it as a whole class, so I'm not doing it in this video. This is a rotations question. The key with the rotations question, always, always, always get tracing paper and check your answer. A lot of people did very well with this. We're rotating at 180 degrees about the point 11, so the point 11 is here. Now, as someone pointed out when we did this in test conditions, it should tell me clockwise or anti-clockwise, but 180 degrees is a half turn, so it doesn't actually matter whether we're going clockwise or anti-clockwise. And we'd end up with the shape over here. I'm just trying to do it quickly. I'm finding that I would need to make sure I'd check this with my tracing paper, but let's have a look. Oh, there we go, I've made a mess of it. something like this, I think, is what we're looking for as a final answer. There we go. That line's in the wrong place. So even if I'm trying to do it quickly, I end up making a mess of it if I don't have tracing paper to check it with. So make sure you get some tracing paper from the examiner, and remember you might have to ask for it. Okay, the next one here is asking for an enlargement by a scale factor of 3. Now everybody should be able to get 2 marks on this, and everyone should be able to get 1 mark, and some people might be able to get 2 marks. So a scale factor of 3, what we're looking at is that this side here is length 1, so it's going to end up as a length of 3, and this side here is length 2, so it's going to end up as a length of 6. So we're timesing all the sides by 3 as a scale factor, and so if we just draw that shape anywhere, so 1, 2, 3, 4, 5, 6 squares up and 3 squares across, then we end up with this shape. If you've drawn that shape, you get 1 out of 2 as long as you've drawn that shape that size. If you're going for both marks, then what you've got to do is put a line from the centre of enlargement, which is 0, 0, through the corner of the first shape, and that same line should hit the corner of the second shape, the same corner. And we can do that for all the corners. Now it's a bit scruffy there, but if you check it with a ruler, that should be in the right position. Okay, so 4-pint bottle of milk and a 6-pint bottle of milk. There's lots of different ways of doing this. I think the sort of most straightforward would be to say how many pounds per pint. So if we're doing pounds per pint, then we're going to do £1 for the 4-pint bottle, £1.18 divided by 4. And for the 6-pint bottle, we're doing £1.74 divided by 4, and we work out how many pounds per pint. So if it's pounds per pint, it's the price divided by the number of pints, not the other way around. And dividing by 4, now it's a non-calculator paper, so we need to remember a trick for this, and the trick is that if you are doing a division by 4, then it's half it and half it again. So half of £1.18, well, that's 118 pence. Half of 118, well, that's going to be 4. Half of 110 is, half of the 8 is 4. Half of 110 is 65, so 65 and 4, so 69. Then half of 69 is going to be, well, half of 60 is 30, half of 9 is 4.5, so 34 and a half. Have I made a mistake there? That number doesn't ring a bell from the mark scheme. Let me just double check it. We have made a mistake there. Where's the mistake come in? Let me just pause it and try and work it out. Yeah, I've made a mistake, which was half of 118 is 59, not 69. So 59, and half of 59 is 29.5. So 29.5 pence per pint. And then for the 6-pint one, it's 174 pence for for 6 pints. Oh dear, I'm making loads of mistakes on this question. 174 pence for 6 pints. So if we divide it by 3, that would tell us the price for 2 pints. Or we could do it 174 divided by 6. How many 6s fit into 174? But whichever way we do it, we're going to get how many 6s fit into 17? That's 2. And 5 left over. How many 6s fit into 54? That's 9. So it's 29 pence per pint. So the 6-pint bottle is cheapest. This one is one that you may remember from Year 10. It's to do with internal and external angles, but again, we haven't covered it as a whole class this year, so although some people might be able to get some marks on it, we don't need it for a grade C. You might want to have a go at it though. This one I put a dotted line round because we can get some marks here. We have done this one, even though it's quite a tricky question, so let's read it carefully. You can change temperatures from degrees F to degrees C, so that's degrees Fahrenheit to degrees Celsius, by using this formula. F is the temperature in degrees F, C is the temperature in degrees C. The minimum temperature in an elderly person's home should be 20 degrees. Mrs. Smith is an elderly person, temperature is 77 degrees in Mrs. Smith's home. Decide whether or not the temperature in Mrs. Smith's home is lower than the minimum temperature should be. So, what we're going to do is that C is 5 times F, which is 77, minus 32 divided by 9. So we're just going to take this here and we're going to substitute it in instead of the f that's in the formula. And then we're just going to work this out. So that's 577 take away 32 is 45. 5 times 45 divided by 9. And the final answer there, we've got to work it out somehow. You've got to be a little bit careful with that. Maybe do 5 times 45 first and then divide by 9, or there's other methods as well, but we're going to end up with 25 degrees C as our final answer. So decide whether the temperature is lower than the minimum temperature. No, it's perfectly fine, it's 25 degrees. So that, now the second part of this question is a bit tricky, so we're leaving that one. Question 13, the key to this one is this word estimate. We don't have to do things exactly here, we just have to have an estimate. So there's a prize won every 2014 seconds, so there's a prize won every roughly 2000 seconds. Now in the mark scheme, it said here that if you rounded any number, any of the numbers that you need to one significant figure, then you could get a mark. So if we just write down 2000 for this question, we do actually have a mark. So there's a prize won every 2000 seconds. We need to work out how many seconds there are in 24 hours. Well, there's 60 seconds in a minute, so 60 minutes in an hour, and 24 hours in a day. So 60 times 60 times 24, so 60 times 60 is 3,600 times 24. So we could probably do 4,000 times 20, which is 80,000. So there's 80,000 seconds in a day, 20,000 80,000 seconds a day. Every 2,000 seconds somebody wins a prize. So we're doing 80,000 seconds divided by 2,000, and that's the same as 8 divided by 2, so about 40 prizes in a day. Watch out for that word estimate. A lot of people tried to work out the exact answers here, and you end up doing an awful lot of work. This one, again, on some of the other papers I've actually been through these questions. It's speed, distance and time. We haven't done it this year, so I'm going to miss it out. You'll notice there's quite a lot on this paper where we were quite unlucky, really. The material that we covered this year, there were a lot of other questions that came up that we haven't covered, but there's still plenty of marks to get our grade C. If you are one of those people that's looking at a grade B, then I know this is the sort of thing that you've looked at in addition to the stuff that we've done all together. Okay, so with this question here, this is something that we can do. It's a bit of a tricky example, but the way that we do it is we'll split this equation up, and we'll have the x squared part, and we'll write that out. So x squared, when x is minus 1, x squared is 1. When x is 0, x squared is 0. When x is 3, x squared is 9. When x is 4, x squared is 16. And then we've got this bit here, so I'm going to go for a 2x row. So when x is minus 1, 2x is minus 2. When x is 0, and we'll just fill in 2x for each row. 6 and 8, and then what we're going to do is we're going to do the x squared row, take away the 2x row, take away 1. So for this bit here we got 1 minus minus 2, that's 3, take away 1, that is 2. Here we're going to do 0 minus 0, take away 1, so that's minus 1. Here we're going to do 9, take away 6, take away 1. So that's a 2, and here we're going to do 16, take away 8, take away 1, so that is 7. Now the next part of this, we've got to plot those points on the graph. Now remember, it's one smooth curve through all the points, and we're going to, let's have a look, let me see if I can, there we go. So this isn't going to be very accurate, you'd have to do it with a nice sharp pencil and things. It's going to be a bit scruffy on the iPad, but here we go, from minus 2 up to 7, minus 1, 2 is here, 0 minus 1 is here, 1 minus 2, 2 minus 1. As you can see, these points aren't exactly where they should be, but you get the idea. Make sure you've drawn them exactly on your proper paper. And we've got this sort of U-shaped curve here, which you might recognise from some of the graphs that we've done. Watch for this sort of thing. If you're doing it with a pencil on a proper piece of paper, you should actually make sure your curve goes straight through all the points. The last part of that question, not something we've covered this year, I'm going to skip over that one. Number 16, the interquartile range, that's the upper quartile take away the lower quartile. So that is this number here, now that value there, well, if this is 5.5 and this is 6, then every 2 squares are worth 0.1, so that is 5.6. Here, we've got 4.5 here, so that's 4.6, 4.7, 4.8, 4.9, so it's halfway between 4.8 and 4.9, so that is 4.85. So the interquartile range is the upper quartile take away the lower quartile. In other words, 5.6 take away 4.85, and we're going to have to work that one out quite carefully, aren't we? But whichever way you work it out, we end up with 0.75 for that answer. So watch out for that one. Watch out for the scales on these things always. The number of players around a distance of more than 5.6. Now this is a bit of a tricky question, but 5.6, look, we recognise that from here. And that is the upper quartile. And if you remember, the upper quartile is a quarter of the data you've got. And it says here there are 80 players, so there were 20 people that ran more than 5.6 kilometres. Now, to compare the distribution, what we've got to do here is look at both of our box plots together, and what we can look at is the median, the upper quartile, the median, the interquartile range, and the lower quartile. So we'd write those three things down: median, interquartile range. Sorry, that's the lower quartile. Median, interquartile range, and range. And we need to say where they're higher and where they're lower. So this is the first half, and this is the second half. So the median is higher in the first half. The interquartile range is actually exactly the same on both of them, and the range, well, here it goes from 4.2 by the looks of it up to 6.4, so that's 6.4 take away 4.2, and here it goes from 3.6 to 6.1, so it's 6.1 take away 3.6. Now, without doing those takeaways, I can see that this one's going to give me a bigger answer, so I'll put higher in second half. Okay, so we might want to actually, if we run an exam paper, do those calculations, make sure we've got the answers. For both marks there, you need to put one of those comparisons in the context of the question. So the median, we could say, on average, people ran further during the first half. Not many questions left. I think this might even be the last one. But one thing that we all want to watch out for, anything to the power of 0, always the answer is 1. Just be ready for that one. You may be able to tackle the standard form question here. Not everybody's looked at standard form, so I'm missing it out in this video, but if you've looked up standard form, and if you've done that at some point this year, then well done. You can have a crack at that, and there's some extra marks for you. I think that is the last question that we're going to tackle. Let me just double check. Yeah, it is the last one on this paper. Oh, no, it's not. Here we go, number 23. Now, in this example, what we're used to doing on these things is, look, we've got a 7/10 here. If we put a 3/10 here, then that gives us 1 mark out of 2. This is a bit of a tricky question. If we read it, Yvonne is taking 10, has got 10 tulip bulbs. She takes 2 bulbs from the bag, and she doesn't put the first bulb back before taking the second bulb out. So at the second stage, there are only 9 bulbs left. So if she's taken a red bulb, then there are 6 red bulbs left out of 9, and there are 3 yellow bulbs out of 9. If she took a yellow bulb at the first stage, then 7 out of 9 of the bulbs that are left are red, and 2 out of 9 of the bulbs that are left are yellow. Now, if you missed this bit, don't worry too much, because you'll have got 1 mark out of 2 for this bit over here. The probability that at least one of the bulbs will grow into a yellow tulip, well, that would be this branch here. It could be this branch here, because there's 1 yellow along this one. So if you remember, what we did was we put a star next to the branches that we want, and then we times along the branches, so 7/10 times 3/9 for this first branch. The second branch, we've got 3/10 times 7/9, and the last branch, we've got 3/10 times 2/9. Let's work those out. 7 times 3 is 21, 10 times 9 is 90, 7 times 3 is 21, 10 times 9 is 90, 3 times 2 is 6, 10 times 9 is 90, and then we've got to add these 3 things together, so 21/90, add 21/90, add 6/90 is 48/90 for the mark. if I've done that add up correctly. I think I have. Okay, now that really is the last question on the paper that we're going to have a look at. So this questions here, which are grade A star stuff, so we'll ignore those. And that's the end of this video.